Hi guys, now we'll see today's LeetCode problem of the day, which is smallest missing multiple of k. So here we are given an integer array nums and an integer k. We have to return the smallest positive multiple of k that is missing from nums. Like we are given an integer array nums and integer k. Now smallest positive multiple is like we'll start from k and see if k is present in nums or not. If it is not present, then it will be our answer. If it is present, then we'll move to 2k and see if it is present or not. If it is not present, then 2k will be our answer. Else we'll move to the third multiple, that is 3k, and do the same until and unless we get the multiple which is not present. That will be our answer. So it is also given that multiple of k is any positive integer that is divisible by k. Like we'll see example to understand it in a better way. So this is nums array and this is k. So what we'll do, first we'll start with k and see whether this is present or not. Since this is present, then we'll move to next multiple, that is 2k, that is 4. 4 is also present, we'll move to next multiple. That now 6 is also present, now we'll move to next multiple, that is 8. 8 is also present, we'll move to next multiple, that is 10. 10 is not present, so 10 is our answer. Now here this is nums array and our k is 5. First we'll start with 5 and see 5 is present or not. It is not present, so 5 will be our answer. So now we'll see approach. And if we see the constraints here, the constraints are very small. So even we go of n square brute force approach will work. So the simplest thing is start from k and keep on moving to next multiple of k until you reach a multiple that is not present in this nums array. And for searching whether this target is present in nums array or not, we can simply apply linear search. Like we'll see code to understand it in a better way. So here this is a simple linear search vector where we are giving nums vector and target. We are just traversing in nums vector and seeing if the any element in it is equal to target, then we'll return true, otherwise we'll return false. Then in our main function, we are simply starting from k and we are searching if it is present in nums or not. If target is not present in nums array, that is only what we are searching for, so we'll return the target as our answer, otherwise we'll move to next multiple. And at last, this I have written return minus one. Just some compilers, like if you don't write return something, if they are asking for in time return, they give some compile time issues. Otherwise we'll always return some answer from this while loop itself. Now if we talk about time complexity and space complexity, so here if the multiple value is m which is not present, so number of iterations will be m by k. And every time we are doing linear search, which also we'll use we go of n time complexity for this also, so overall time complexity will be m by k into n. And in worst case, if k is 1 and all the elements are present in nums, it will go to n square. If we talk about space complexity, we are not using any extra vector or array something, so space complexity is constant. Now can we do something better? So like what if we sort this nums and instead of doing this linear search, we can do binary search. In that way, the for every iteration now we go of n time complexity. In case if we use binary search, then it will only require the time complexity of log n. So let's see the binary search approach. So here I have written the standard binary search approach where we are taking the nums target and what is the size of this nums, and initializing low with 0, high with n minus 1. While low is less than high, I am finding the mid. If the middle element is equal to target, that means we got the target, return true. If target is less than the middle element, then we our answer will always be between low and mid minus 1, so we'll move high to mid minus 1, otherwise we'll make low equal to mid plus 1. If after doing all these iterations still we are not able to find the target, that means target is not present, we'll return false. So this is our main function. Here I have taken the size of nums, then sorted the nums array so that I can apply the binary search. Now we are simply doing same, searching the starting from smallest multiple of k and seeing if it is present in nums or not. The moment we get the multiple which is not present in nums array, that will be our answer. If we are getting the multiple which is present, then we'll move to the next multiple. So in this way, like if we talk about time complexity, then sorting will take n log n. And here if the r multiple which is not present is m, so total number of iterations will be m by k, and each iteration will require a search time of log n because we are using binary search. So it will be, time complexity will be n log n plus m by k log n. And in worst case, if k is 1 and all the elements are present in nums, so it will be n log n, so 2 n log n. And if we talk about space complexity, then only this sort will needs extra space which is log n and no other space we are using. So time space complexity will be big O of log n. Now, in both the approaches, for every iteration, we were applying some search technique where we need to traverse the array and see whether the target is present or not. Can we do something better? Like, what if we store all the elements in some data structure where we can get constant time lookup? For that we can use unordered set. So in next approach, what we can do is we can simply store all the elements of the nums in unordered set, and here simply we can search if the target is present in that or not in constant time. And if it is not present, then we'll return the target. Like we'll see the next approach to understand it in a better way. So here I have stored all the elements in the unordered set. Now I am starting from the smallest multiple of k and seeing if that is present in the map or not. If it is present, then I'll return the target. Otherwise, move to the next multiple and try that again. So in this way, if we see, we have significantly reduced the time complexity. Like earlier, every time here we were taking in first approach, we go of n search time complexity, and in second also log n. But in this, for every iteration, we will be able to do constant time lookup. So if m is the like multiple which is our answer, so number of iterations will be m by k, and our time complexity will also be O of m by k. And if k is 1 and all the elements are present in the array, then it will be O of n only, worst case. But here we are using an ordered set to store all the elements, so there is a trade off. We will need extra space complexity of O of n.